All right, this is a transformer. So what I'm going to do here is I'm going to slowly put this transformer together so you can see each and every part of it. So if you're not in a spot where you can see me, or if you're sitting down back there at the last station, you're going to have no idea what's going on, and therefore you're going to do very, very poorly on the lab practical. So if y'all need to, y'all can fill in over here somewhere. Okay, so this also demonstrates Faraday's law of electromagnetic induction. Y'all remember in the notes we talked about that iron ring? So it's kind of the same thing going on here. So notice that I have two complete circuits. Here I have a light bulb that is connected to a coil of wire. This coil of wire has 200 turns. That means it wraps around here 200 times. Do y'all see that? Are there any batteries connected here? No. In this other circuit, I have another coil of wire. This one has 800 turns. And that's important because I'm going to make what's called a step-down transformer. And I also have another light bulb connected here, and I have power supplied from here. So what I'm going to do is I'm going to turn on, notice I have to use AC power, because in order to induce a current into this coil, I need the magnetic field to change with time. Go with me? So, I turn it on, and I'm going to give it enough power to light up this light bulb here. So here we go. I don't want all these on. Just want that one on. All right, so does everybody see I have this one light bulb is lit? The one light bulb is lit. Turn it down. I don't want to burn it out. So everybody can see this light bulb is lit, correct? Yeah. That means current is flowing in these wires, even in this one here. This is a coil of wire. It's very similar to the electromagnet you saw, except is there any iron in it? No. No. So what I'm going to do is I'm going to put iron into it. Okay, so I want y'all to observe what happens is I put the iron into the core. Y'all ready? Anything different? What happened? So what's happening here is as I add this iron core to this coil, it increases the resistance of this part here. So I need to use more voltage on this coil, so less is available for the light bulb. Make sense? Yes, and the amps went down because the total current of the circuit increased. And remember, if I keep the voltage constant, as voltage stays constant, resistance increases, current will decrease. Good. So now I'm going to increase my current a little bit more so I can get my light bulb back up to where I had it. Go with me? Now what I'm going to do is I'm going to add this coil to the other side, because now this thing has made an electromagnet. Notice this has a rather unique shape. It's kind of U-shaped. That way I can put the other coil on here very easily. All right. So y'all tell me if you notice anything with either light bulb. Is that one on? No.
Close it.
You look very carefully. Just a little bit. So if I turn up the current here a little bit more, can y'all see that that's on just a little bit?
Yeah.
Just a little bit.
What happens if you put the top on?
That's a very good question. I have a top here. So if I take this and I put it on this side, listen, observe what happens if I put it on this side. Did that make this light bulb any brighter? But what happened to this one? That's significantly dimmer. Do y'all see that? That's because this has more iron and it's giving it more resistance to the circuit. Do y'all see that? It's making a bigger magnet. What if I just put it on the other side? It's a little bit brighter over there. Do y'all see that? What if I put it on both? The resistance has increased so much that this light bulb has actually gone out. And look how bright that one is now. So here, even as I turn the current up over here, this isn't even lighting up, but I'm not going to turn it up anymore because that one's going to burn out if I go much brighter. Y'all see that? So this shows, this is a transformer here. That is a transformer. It changes the current and voltage in both of these circuits. Do y'all see that? Transformers are everywhere. If you plug your cell phone into the wall, that little box is a transformer. You plug your PlayStation into the wall, That big box on the cord is a transformer. Gray or white cylinders up on the telephone poles, those are transformers. The things in the green boxes on the ground out in front of your houses, those are transformers. Across the street, that power substation that you see right there across Teasley, that's transforming the power from high voltage power lines like 10,000 volts and stepping it down to more like 1,000 volts to go into your local neighborhood, which will then be stepped down again by those green transformers that are in your front yards to about the 120 volts that goes into your house. And then when you plug in your cell phone through that charger there, it steps it down once again to only about 5 volts for use in your cell phone. Yes. All right. The last thing I'm going to show you is the fact that this is alternating 60 times per second. If you listen, if I kind of set this thing off to the side, see if I can get it to resonate here. Why did I do that before?
Does it like make heat? Good talk.
Well, it's kind of difficult to hear with everybody talking so much. So I'm just going to stop that. So I need y'all to stop talking.